All right, so in this video, I'm going to talk about dual coding and how we can use that to support our learning. So when we talk about dual coding, it's really pairing information in verbal and nonverbal formats. And sometimes you'll hear this called multimodal learning, with the idea that we're kind of processing information in different modalities. So as a simple example, it would be something like reading text. That would be the verbal processing of information, and then maybe looking at diagrams or figures, right, which would be more visual processing. And this is something I used as a student quite a bit. When I would go into the cadaver lab, if I was studying anatomy, I would bring my anatomy textbook and I'd kind of read. That would be the verbal part, the text. And then I would kind of flip over to look at the cadaver, right? I would say, okay, I read about this structure. Now let me visualize it, right? Example of pairing verbal and visual information together. Same thing when I would study outside of the lab. I would maybe have my atlas in my textbook together, and I would read and I would look at images, or I would read, if I was reading for physiology, I would read and then try to find a diagram, right? So again, it's this idea of kind of pairing information in different modalities or different formats, verbal and nonverbal. There's a decent amount of research that would tell us that it improves our knowledge retention and promotes critical thinking when we can kind of look at different information in different forms or different modalities. So just as an example, this was a study conducted by Richard Meyer and Joan Galini, where they had students, undergraduate college students, read passages about different devices. So they had them read about, I think it was pumps, brakes, and generators, just really basic devices. And some of the students either just read. That was just the verbal group. They just read through text. And other students read and also looked at diagrams of how the different devices work. So you can see an example on the right of a diagram and showing how a pump works, right? So they did a post test, and they found that the students that kind of compared or combined that verbal and visual information, so reading but also supplementing that with diagram, recalled more information than the students who just read the passages, right? And probably the more interesting thing is they also gave them a bunch of problem solving scenarios. So they would ask them questions like, imagine you press the brakes and they're not working. What could potentially have gone wrong with the brakes, right? So students would kind of have to problem solve potential issues based on their understanding of how brakes work, right? And they actually found that the students that paired verbal and visual information together, so read and looked at diagrams, were actually better able to problem solve potential issues. Now you're probably looking at this and you say, okay, if I'm training to become a healthcare provider, why do I need to know about how brakes and pumps and generators work? Well, I think, if you think about it, you could say, well, yeah, this does make a lot of sense, because I can think of the different systems of the body, and I would probably want to understand not only how they function and have a pretty good understanding of how they function, but also understand what could go wrong if we're seeing potential issues, what the potential problems could be, right? And actually, I kind of pointed out in the last bullet point there's a study that actually kind of took the same approach, where they compared students who just read about the respiratory system versus students that read about the respiratory system and then watched animations of how the respiratory system worked. They kind of find the same thing as Meyer and Galini's study did, that students not only had a better understanding of the respiratory system, but they were better able to problem solve potential issues when they combined text and visual information, in that case, animations, right? So why is it important to kind of pair these different sources of information, right? And there's a bunch of different ideas, but a lot of it kind of stems from this idea of kind of how we process different sources of information within our brain. And it comes down to something that Alan Paivio was really the person who has posited this kind of what he calls dual coding theory, which again just means that we process different sources of information differently within our brain. So this kind of shows a very simplified outline of dual coding, right? Where we have verbal inputs. So this is something like text we read, or if we're listening to something. And then we have visual inputs. So this could be something like images, diagrams, cadaver specimens, prosections, those kinds of things that we can visualize. And it shows different channels or subsections or subsystems in the brain processing these information individually, and then those information, visual information and verbal information, getting stored in our long-term memory, right? This is kind of the crux of dual coding theory. Probably an oversimplification, but this is the idea, right? So the key point here is that our brain processes these two sources of information separately, and then they get interconnected in our long-term memory. So the idea is if we can process information in both verbal and visual forms, we can enhance our representation of whatever we're trying to learn in our long-term memory. Think of it as developing a more robust memory framework with both visual and verbal information stored together, right? The other thing you'll see here is that there's an interconnection in our working memory between visual and verbal information. It's why if you see a picture of a nose or an eyes or a face or something like that, just as an example, it helps you come up with the word for those structures a little bit more easily. Or if you read about those structures, right, you probably create a mental image of those kind of structures. You almost visualize a nose, ears, face, right? So again, these verbal and visual information are processed separately, but they are interconnected, right? So essentially, when I think of us using dual coding when we're studying, it's basically studying in a manner that's conducive to how the brain wants to essentially store information. All right, so as far as some really basic tips for how we can leverage dual coding when we're studying, one is to study verbal and visual forms at about the same time, right? It probably wouldn't benefit you to really focus on your reading, like read through all the text, and then shift over to focus on, like once you've finished your reading, then shift over to look at visuals, right? You want to create temporal alignment between the two. Like I said, maybe you go into the cadaver lab and you read the text, and then you look at the visual, the specimen or the prosection, then you go back to the text. I always think of, if the more you can pair those things together, the more you create these rich and elaborate memory frameworks. And again, I think text can be great for adding in a lot of details, and then models, diagrams, images can help you see the bigger picture and how things relate to each other, right? The other point I would say is rely more heavily on visuals when you're first learning about something. There is some truth to the idea that a picture is worth 1,000 words, right? And this is based on some research that they found that, pairing text and visuals is really helpful if someone's a novice, right? If they're just learning about how a device works or how a system of the body works. But it's not that helpful for people that already have a pretty good understanding of that system, right, or that device, right? And the idea is if you actually already know quite a bit about how a device works or a system works, you probably already have a mental representation of it, so it doesn't help you that much to look at visuals or diagrams. It's certainly not going to hurt you, but when you're first learning a topic and you're reading through it, you probably want to search out and see if you can find a diagram that shows how the information is organized, or a figure that kind of shows you some kind of image of how it's structured and how it's designed, right? The last point I would say is generate your own visuals. So, it's great to look at your textbook and look at your notes and understand the visuals, but there is a lot of benefit to generating your own visuals. Think of Bloom's taxonomy. It takes you up to a higher level, right? From understanding when you look at a visual is one level, but it's certainly going to be a higher level if you can actually generate your own visuals. And this is where I think you can, if you're doing something like creating a diagram or creating a infographic, the type of visual you use can differ depending on the course you're taking in the subject. But I think if you generate your own diagrams or visuals, it can be a nice group study activity, right? Where you can each generate your own diagrams and visuals, and you can kind of talk other people through it. One, you get the benefit of talking somebody through your visuals. And then if you're on the other side of that, you actually get the benefit of them explaining and showing you how they contextualize this information, right? So I think this is going to be a great group activity as well, or at least pairing if you're working with a partner. So one thing I wanted to kind of highlight is sometimes this dual coding idea kind of gets mixed in with this idea of learning styles. So there's this concept of learning styles, and that became popular in education in like the 90s, which was the idea that each of us has a way that we learn best. So some people learn best by looking at visuals. Some people learn best by looking at reading and listening. Some people are kinesthetic learners. They say they have to move and they have to, process information that way and stuff like that. And while that's an interesting theory, when they've done studies on it, they really haven't shown that it's that effective, right? It actually makes a difference. There's not much evidence to support that premise. If you took someone who's a self-described visual learner and you actually had them focus primarily on trying to learn using visuals, and then you had a person that was more of a so-called verbal learner, and you gave them mostly text and audio to review, and then you gave somebody who's a kinesthetic learner and you designed the learning activities towards that. There's not much that tells us that there's much benefit to kind of matching someone's learning styles with how they process information. Dual coding is a little different. It's not saying that you have a specific style that you should lean into. It's basically saying that we should process information in a lot of different formats, right? We should rely on text in some cases, but then we should mix that in with visuals like diagrams, images, maybe kinesthetic. If you can move through an activity or something like that, that may support other text. So it's kind of like you want to process information through as many modes as possible, right? To create these kind of robust mental representations of what you're trying to learn, not necessarily focus on just text because that's what you feel like you learn best, or just visual because that's what you feel like you learn best, right? So this is where I just wanted to clarify that dual coding is not necessarily learning styles, right? If you're familiar with that concept. Like where I said, there's not much evidence to support this idea of learning styles as important in how effective we are at learning different information. There is a lot that says that dual coding, which again is just mixing these different modalities, is an important concept or an important part of how effectively we learn, right? So as far as final thoughts, I think pairing visual or verbal and visual information when you're studying helps you make some stronger connections. And again, I think it comes down to it supports the development of elaborate memory framework, and it makes it so that the information is sticky, right? It sticks with us, we can retain it, and it's also useful, right? With some of the examples about just better problem solving and things like that. I think this is where we create those durable and flexible and useful knowledge that, again, you're going to need as you move forward and start working with patients.
If you enjoyed this content, be sure to like and subscribe to my YouTube channel, Learning That Lasts, and check out my book, Learning That Lasts, which is available on Amazon.